Part F, finding all linear asymptotes, and we are talking about rational functions. We're not doing the linear asymptotes on like logarithmics or trigs or exponentials or anything like that. And when you're doing linear asymptotes, you do want to factor and cancel if possible. So because unlike domain questions, if something cancels, that actually does affect the answer. So x minus 3, this bottom will factor to x plus 3, x plus 2, and I think I have a typo here because I'm pretty sure I intended something to cancel there, but it doesn't. That's not how that factors. That's not how it factors at all. What am I doing? It's x plus 5, x plus 1. Nothing cancels. Nothing cancels at all, so now I'm ready to think about my asymptotes. And so let's do, to me, verticals are the easiest. Vertical asymptotes. After you factor and cancel, which nothing cancels, you set the bottom equal to 0. Vertical asymptotes are going to be at x equals negative 5 and x equals negative 1, because those are the values of x that make this thing equal to 0, that make the denominator equal to 0. Horizontal asymptotes, that's when you look at your degree on top and bottom. My bottom degree is bigger than the top, which we affectionately refer to as BOBO, I believe. Bigger on bottom is 0, and so the horizontal asymptote is y equals 0. Really not a fan of that BOBO stuff, but some of y'all like it, so whatever. And then slant asymptotes. Slant asymptotes, there is not one, because you only have slant asymptotes when the top degree is 1 degree larger than the bottom. So no slant asymptotes. 38. Again, you want to try to factor and cancel, but actually this one is not going to factor at all. There are no factors of 8 that would add up to 2. So this thing is already simplified. Vertical asymptotes, when the denominator equals 0, so that's going to happen at x equals 3. Horizontal asymptotes, now my top is bigger than the bottom, which we refer to as BO2. These things confuse me. I think that's right. Bigger on top is undefined. That means there is no horizontal asymptote. If the top degree is larger, there is no horizontal asymptote. Slant asymptote, the top degree is 1 more than the bottom. My bottom degree is 1, top degree is 2. That means that there is a slant asymptote, and we get that by doing division. So I could either do x minus 3 into x squared plus 2x plus 8. That's if you want to make life difficult. I prefer synthetic division, so I'm going to say, or we could do synthetic, which would be 3 into 1x squared, 2x, 8. And for synthetic, so I wrote down my coefficients of my x's. I start by bringing down the 1. 3 times 1 is 3. Then we add 2 plus 3 is 5. 3 times 5 is 15. 15 plus 8 is 23. This last number is your remainder, and in the application of slant asymptotes, the remainder is irrelevant. My slant asymptote is the line y equals 1x plus 5. So you do the division, and then you throw away the remainder, and whatever you got for the answer is your slant asymptote. My slant, so it is y equals 1x plus 5. And do remember that all asymptotes are linear equations, so they need to be in the form x equals or y equals something. And that is important. Let's see, number 39. Ooh, we have to factor this one. This is going to be a pain. Okay, so x squared minus 9 is easy. That's x plus 3x minus 3. In the denominator, I'm going to have to play trial and error a little bit with this one. I do know that 3x times x would give me 3x squared. These two have to multiply to give me a 3, and I think I like having a 1 here and a 3 here. If I make that a negative 3 and this a positive 1, then when you expand it, 3x times negative 3 is negative 9x, 1 times x is positive 1x, and those two give you a negative 8x, which is what I wanted. So everything factored correctly. And this one, we finally have one where a factor cancels, and that's important, because if anything cancels, that creates a hole in the graph. So there's a hole at whatever factor makes that equal to 0. So if I said x minus 3 equal to 0, whatever value makes that factor equal to 0 is what I'm going to say. Anyway, the hole is at x equals 3. It is not a vertical asymptote. You have to factor and cancel first. Then my function reduces to x plus 3 over 3 3x plus 1, and now I can continue with the rest of the asymptotes. So verticals, I was left with a 3x plus 1 in bottom, so if you set that equal to 0 and solve, you get a vertical asymptote at negative 1/3. Horizontal, my top is equal to the bottom, so the top degree equals the bottom, which we refer to as Betsy. The bottom equals the top. You divide coefficients. So Betsy, so we will divide the coefficients, and it doesn't matter if you look at the original or the simplified one. The top degrees are equal in both cases, and the coefficients, if you divide them, you'll get 1/3 in both cases. So my horizontal asymptote is y equals 1/3. And slants, the degrees are equal. You only have a slant if the top degree is one more than the bottom, and therefore there are no slants. That's it for asymptotes.